So we just talked about how sedimentary rocks can be metamorphosed and how they can be deformed in the plate tectonic collisions that shove them to great depth to cause that metamorphism. Well, we can metamorphose igneous rocks too. If you remember, the characteristics of igneous rocks are interlocking grains and typically no layering. Well, this is an igneous rock that's been deformed and metamorphosed. And what that deformation does is it can take a rock that has no layering in it and cause a rock to have layering. And in metamorphic rocks that have been deformed, we call that layering foliation. So you can see this is a light-colored igneous rock. So we would call the composition to be felsic. But what it has in it are little clots of biotite. And if you look with your hand lens, you can see that those clots of biotite are all aligned. And they form a streaking in the rock when you look at the surface in this orientation here. And that's, in fact, the foliation caused by that deformation. And that deformation takes biotites that are all randomly oriented and it rotates them into alignment in this fashion here, imparting that foliation, and we can then use that to identify this as an igneous rock that's been metamorphosed, because it still has the interlocking grains just like its protolith, but it now has a layering in this orientation telling us that it's been metamorphosed and deformed and therefore is a metamorphic rock.